Okay, so last time when we were assembling the circuit, I said something incorrect, and that's why the circuit didn't work. So I've jumped to the part of the video that shows the error, and then I'll explain it. So we were in the process of building figure 815, and we were connecting this 10 kilo ohm resistor. So in the video and the live demonstration, essentially, what I said was we needed to connect from the rail to 10, but it's actually this 10 kilo ohm needs to go from the rail to 9. So we'll hear it on the video. So I've made this connection in. So now I want to put the 10 kilo ohm between 10 and the red rail. So, and that's the incorrect part. So if I were to put this 10 kilo ohm between 10 and the red rail, I would actually be connecting the 10 kilo ohm directly to the base of the transistor, but I want it to connect it to the collector of the transistor. And so that explains why the circuit didn't work when we tested it. So I've fixed this since. So on the circuit board, essentially what I've done is I've gone from now the red rail to column number 9. So this is why it's important to label your connections. So this rail is now, or this resistor is now connected to rail number 9, or sorry, from the red rail to column number 9C. So that's right there. Okay, so we'll resume now. So let me stop sharing that window and close the old video. So we're going to resume. So this is our circuit so far. And so this is the correction I made. So I went from the red rail to column number 9 instead of column number 10. So let me start screen share again. And what we want to look at is, okay, so this is our diagram. So assume that we've completed the rest of the video. So this is where we are right now, and we've built figure 815. So the next step is we want to build 817, and this is what you're working on at home. So let's copy the labels of what we've put so far in our diagram onto this new diagram. So let me copy these and then rearrange them. So, wow, I guess this should have done this in advance, but it's fine. Okay, so 4E goes to here. The blue rail we've connected, rail we've connected there. 5E and 2H was where the microphone is. 3J was here. 10B is here. So let me just confirm. 3J was after the capacitor, the 22 nanofarad one, and 10B is before the base of the transistor. 9B is here. And then 11B was the ground. And then 9 is also there. So this so far, and 14 is after the capacitor. So 14 is after the capacitor. Okay, so this is what we've connected so far, and we've also connected the 10 kilo ohm at the red rail. We've connected this, and we've connected the transistor. So now this is the part of the circuit that we want to build. And so I mentioned that it's good to lay out the transistor because this is one of the elements that we have to be careful about which leads we use. There's a few elements before it. So these are probably going to be roughly column 15 or so. So I'm going to put this transistor closer to 18 on the circuit board. So we take out our next transistor. So we have this element. And I'm going to go with, on the board, I'm going to go with the collector. Let me go in row B. And I'm going to do 18, 19, and 20 for the transistor. So what I've done is, so I've made this 18, no, this is 19. This one was 18. and this is 20. And I'm going to change all of the text that I'm adding to a color that we can see clearly. So I'll make it, yeah, I think purple is good because we have nothing else in the diagram that's purple. Okay, so these are the connections that we've made. So I've plugged in the transistor 19B, 20B, or 18, 19, and 20B. So collector in 18B, base in 19B, emitter in 20B. Okay, so now to connect this to the circuit, basically I need a jumper wire from the capacitor to the base of the transistor. So I need to go from 14 on the lower half to 19. So let me pick out a jumper wire and go from 14 to 19. So I've made this connection now between the end of the capacitor, the 100 nanofarad capacitor, and to the base of the transistor. So I've essentially made this connection here. So I've connected the capacitor to the base. So that's this connection. Let's do this connection next. So we need to go from the red rail to the either 14 or to 19. Looking on my board, I have more space in 14. So I'm going to use the 47 kilo ohm to go from the red rail to column 14 on the lower half. So I have one end in 14 and the other end, it happens to be the red rail above 15. So that's this capacitor, or sorry, that's this resistor, 47 kilo ohm, going between the red rail and column 14. So I've made this connection now. So I go from red rail to 14. And just to clarify that point, this is the other end of the red rail for the this is the other end of the resistor that's connected to the red rail. Okay, so now I want to add this capacitor. So this capacitor needs to go between either 14 or 19 and the blue rail. So in terms of what I've connected, so this one I've actually connected to the other transistor. I'm missing one of my labels. I have made this connection here already. So I need to go from 14 to the blue rail, and looking at where I've positioned things, or I need to go from, So I need to go from 14 to the blue rail. Okay, so looking at how I've positioned things, what I'm gonna do, so let me pull out the correct capacitor, so 1 nanofarad. So that's this one in my part sheet. What I'm going to do is I'm going to move one of these, actually it's fine. So in this case, I'm going 14C to the blue rail at roughly 12 on blue. So that makes that connection between column 14 and the blue rail. So I've made this connection now. And just to be specific, this was 14C. This one was 14E. That capacitor was 14A. So that's just the specific ports that I use for this capacitor, this resistor, and this capacitor. Okay, so now let's continue on with, so we've made all the connections up to here so far. We've connected this element. So we now need to finish the connection here. So we need to go from the emitter of the second transistor to the blue rail. So we want 470 ohms. Looking at my circuit, I'm going to use 20A because it's close to the rail. So I take out my 470 ohm resistor, and I'm going to go between 20A and the blue rail at roughly 20, it's like 23. And I'm going to bend my resistor out of the way in the same way that I bent my jumper cable out of the way. And just keep in mind the jumper is insulated, so these two, it's fine if they touch, but if this were a regular metal wire, I would not want my components to touch. So these two capacitors, it's fine if they touch because they're connected to the same column anyway, so I'm good. So, okay, so I've added my 470 ohm resistor between 20A and the blue rail. So 20A, I've made my connection to the blue rail. Okay, so now I need to go, so I can do this. I'm gonna save this one for last because these parts are a little bit trickier to put in. I'm gonna put in this capacitor. So this 5.6 picofarad capacitor, I need to go from 18 to 20. So let me take out the capacitor. And I can just put it, so between 18 and 20. So this is one of the easier ones. So I just plug that in there. Hopefully you can see it. So I just went between 18 and 20. So I'm going to move my board around so you can see the other connections. All right, so that goes between 18C and 20C. Okay, so I've now added this. This is taken care of. These two elements need to connect. This element needs to connect, and the 22 nanofarad need to connect. So while I'm still on 18, I may as well do this other capacitor. So this other capacitor is 27 picofarad, and I need to go from 18 to some other location. So I'm going to pick, let's see, 27. So this needs to go to some other spot. I will get it to, let's go to 22. So I'm going from 18E to 22E. So 18E to 22E. Yep. Okay, so we've connected that, and while we're at 22E, we can connect the antenna. So you saw me struggle with trying to strip the wire. I think it just takes a little bit of practice. And then we want to plug this wire now into, this is our antenna. We want to plug this wire into 22 in some one of the rows. So I'm just going to pick 22C. And it looks like this wire is slightly too thick to fit in. So what I'm going to do is I'm going to pull back a few of the strands so that this is a thinner object. So at the very tip, I have slightly fewer strands. I'm also going to twist it a bit more so that I can get a sharper tip to be able to plug into the protoboard. Let's try this again. Okay, it's kind of going in, but I'm not confident in it. So I'm going to remove a few more strands. And I'm going to twist it a little bit more. Because every connection that I make, I have to ensure that it's actually connected inside the protoboard. So I need to make sure that things plug in. So you can see it's a little bit thinner now. Make sure that things actually plug into the protoboard. Okay, so eventually on the other end of the antenna, we're going to be stripping away 3/4 inch. So let me go ahead and strip away 3/4 inch. Part of why I'm doing that now, so this is going to be during the testing. So I need to carefully remove the insulation on sort of the last bit of the antenna. So part of the reason I'm doing this now is because I can test to see whether this is properly plugged into the board. Yeah, so that one worked much better. So on this end, I'm going to twist this. So what we want to check is whether we've made continuity. So in order to do this, probably the best way, okay, so I'm going to take out my probe from the battery clip, and then we'll do this part again later. So what I want to check on my digital multimeter is I want to go to the setting where it's the beep. And so this is going to check to see whether I've made an electrical connection. So if I touch the two things together, it beeps at me, meaning that it's electrically connected. So what I want to see is if I touch one end, so let's say it doesn't matter red or black. So I'm making contact between the other end of the antenna and the red. And then I want to probe and just see, okay, well, if I probe the wire, of course it's going to beep, but I want to see it's electrically connected to the pin. So if I probe the other leg of the capacitor, I can see that, yes, this is properly plugged in. Okay, so now I have my antenna plugged into the circuit, and I've plugged it into 22C. Turn off my multimeter. Okay, so this other end of the antenna is in 22C. Okay, so I've connected all that. Let's do this 22 nanofarad. This is a relatively easy one to connect. I just need to go between the red rail and the blue rail with the 22 nanofarad capacitor. What this does is it helps suppress any fluctuations from our power source. So I need to go between these 2 points. So with my 22 nanofarad capacitor, so you can see the length is not long enough to jump all the way from one side to the next. So what I'm going to do is I'm going to connect. So this is between the red and the blue. I'm going to connect it at the top. So I'm going to create a ground connection at the top. I'm going to put this very far away. So I'll put it in, actually, let's go into, I don't want to go too far away. Let me go into 27 roughly. So this is going between the red and the blue, but currently I'm not using this top blue rail. So in order for me to use it, I need a jumper wire between the bottom blue rail and this top blue rail. So this one, I'm actually just going to put very, very far away. So I'm going to put this between 5 and 1. or 3 actually, of this blue rail. So what I've done here is I've plugged in to jump between this bottom blue rail and this top blue rail so that it's more convenient for me to plug in the capacitor. It'll also be more convenient when I plug in the battery, because now the battery clip can just go on one side rather than having to span the two. So I've connected the blue rail here to the blue rail there. The bottom red rail is still unused. Okay, so this capacitor, what I've done is I've connected from the red rail. Oops. And I've connected it to, this is the top blue. And let's put that here. So I've put the capacitor between the red rail and the top blue rail, and I've put a jumper wire between the top blue rail and the bottom blue rail, which we've just been calling blue rail. Okay, so I've made this connection here to here with a jumper wire. And so my capacitor went from the red rail to the top blue rail, and then I have a jumper wire from the top blue rail to the bottom blue rail. All right, so the last two components that we need to insert, so we are putting the variable capacitor and the inductor in parallel between the red rail and column 18B. And the function of this is known as a tank circuit. So the function of this part of the circuit is that you have a tunable resonance. So this circuit, there's a transfer of energy between the electric field in the capacitor and the magnetic field in the inductor. Essentially, when you charge up the capacitor, what happens is that there's a charge that wants to move and flow current into the inductor. So if we just look at this part of the circuit and not think about anything else. So if I put charge on the capacitor, if I ordinarily connect this to like a resistor, the charge will just flow through the resistor and energy will be dissipated. But in this configuration known as the tank circuit, the electric charge that's on the capacitor, it wants to flow into the inductor, but the inductor is a device that resists instantaneous changes in current. So it creates a voltage across the inductor, because as I change the current, basically I'm moving charge into this. This you can think of as a series of coils. You're changing the magnetic flux through the inductor, and that has a back electromotive force associated with it. So basically this resists, or I shouldn't say resists, there's charges that are on the capacitor plate that try to move and flow current into the inductor, and then the inductor opposes that flow, and it basically builds up a magnetic field, and then that magnetic field stores energy, and then that energy that's stored can go back into the electric field associated with the capacitor. So there's a flow of energy between these two, and the frequency at which it flows best is the resonant frequency, and that's the frequency that you're going to radiate your FM wave. So this FM wave, it's these capacitance and inductance, along with some other capacitances and inductances in the circuit, this is going to have a resonance frequency in the FM band, so in the 88 to 108 megahertz frequency range, and you'll adjust this capacitor to tune it to the station that you want. Okay, so I think I mentioned this in the previous video, the functionality of this transistor. It's not serving to amplify. What it's serving to do is the signal that we had coming into here, this is changing charge that's in the base of this capacitor, and it's changing what's known as the depletion width of the capacitor. So essentially you can think of it as, if I have current flowing into this and it's alternating as a function of time, then the capacitance of this element changes as a function of time. And so this capacitor with this capacitor in series, okay, these two are in parallel, but that being in series with this capacitor inductor combination. So all of these things taken together, this forms something that's going to convert a sound wave into a variable frequency, so a frequency modulated wave. And then that's what we're going to send and radiate with our antenna. So, all right, so we want to connect these two elements. So the next component that I'm going to work with is the variable capacitor. So let me find that. Okay, so I can put these two elements on the top half of my board. And so I'm going to work in open space. I eventually need to connect it to 18. So the space that I'm going to work in, I'm going to use, let's say 16, it looks like I'm going to go 16 and 18. Let me use H for the capacitor. So this capacitor is going currently 18H and 16H. And so you can see now I need a jumper wire between the red rail and 16H, and 16. So let me put in that jumper wire between the red and 16F or 16J. Maybe I should have put this in first and then put in the capacitor. Try a different one. Yeah, you can see it takes a little bit of patience and a little bit of practice to plug these wires in. Okay, so from there to there. There we go. Okay, so it's going between this red rail and 16J. So I've plugged in the capacitor between 18H and 16H, and then I put a jumper wire between 16J and the red rail. So the final step in the circuit is to add the inductor. So I want to go between 16 and 18 on the upper half. So the inductor is this part. So in the past, we used to use a coil. The coil is a relatively cheap way to realize the inductor. You have to play around with the geometry of the coil, like the number of windings and the space between windings and so forth to get a specific value. This gives us a guaranteed value for the inductance, so it's much easier, but this is actually one of the most expensive, or it is the most expensive component of all these. So this one, when purchased in bulk, was about 75 cents. All of these individual components, when purchased in bulk, probably add up to 75 cents, except for maybe the variable capacitor and the wire. Interestingly, this wire is pretty expensive given the length of it. Okay, so we need to go between 16 and 18 for this inductor. So I'm going to pick column F. So I'm going between 16 and 18. Oh, okay, so so the other thing that I'm noticing is for 18, I was working in the top half, and this, these parts here are in the top half of the board. These are in the bottom half, so I'm still missing this jumper wire here to here. So I've added the inductor between 16F and 18F. So let's record that. So the challenge is this looks like it looks like we're done. The problem is the top half of the board is not connected to the bottom half. So I'm missing the jumper wire between 18 at the top and 18 at the bottom. So let's add another jumper wire. And it looks like the available space, I can go between 18, let's say 18J and 18D. Okay, so I have that, and I'm going to move it out of the way. All right, so assuming that I have not made any additional errors when assembling the circuit, the circuit is complete. So this last one went from 18J to 18D. Okay, so let's look through our circuit schematic, make sure it agrees with what we've built. So starting at the top, the microphone was going between 5 and 2, or sorry, between 5 and 4. On the bottom, I have something going from 4 to the blue rail, so that's connected. I have the 22 kilo ohm resistor between, let's see, 22 is between the red and 2H, so that's this one. So that's connected there. I have a jumper wire essentially between 2H and 5, and column 5. So this is connected there. I have this 22 nanofarad capacitor between columns 2 and 3. That's up here. I have the 1 mega ohm resistor, this one, between the base and the collector of the transistor. So that's this one here. I have the 10 kilo ohm going from the red rail to column number 9 at the bottom. So I fixed that. And then I have transistor between 9, 10, and 11. So collector in 9, base in 10, and emitter in 11. So I can hold this up a little bit so you can see it. And then I have 11 connected to ground. So that's this orange wire at the very bottom. I have this capacitor, 100 nanofarad. That's this one going between 9 and 14. So that's there. I have a 1 nanofarad capacitor going between 14 and the blue rail at the bottom. I have 47 kilo ohms going from the top to 14. That's there. I then have this transistor in 18, 19, and 20. That's there. I have the 470 ohm resistor between 20 and the bottom blue rail. I have the capacitor between the collector and the emitter. So that's 18 to 20. So that's this one. I have this 27 picofarad going between 18 and 22. So that's this one here. I have this antenna. The antenna plugs in on one end, the other end is free. And then for this inductor capacitor tank circuit, I have from the red rail going to the top 16J. And then I have the capacitor between 16 and 18. I have a jumper wire from 18 top to 18 bottom. And then I have the inductor between 16 and 18 on the top. So that completes that circuit.